Hi folks, thanks for joining me as we are going to talk about how sound works. And that'll lead into how humans hear and how computers hear. Okay, so the basics, just like sound, or just like light, sound is a wave. If you want to think about it as a vibration, that's fine, but the technical physical term is a wave. But sound requires a physical medium, such as air, so e.g. air, water, uh, wood, anything where you've got physical stuff that's actually there. It requires a physical medium to transmit or to travel. So the wave is traveling through that. And the reason is because the vibrations in sound waves are changes in pressure. So in other words, we either pack our particles slightly close together or we spread them out. So a wave would look maybe, a sound wave might look something like this if you could look at it really close in the air. You've got a bunch of particles really closely packed together. Then the air particles are kind of spread out. Then they're packed together again. Then they're kind of spread out and they're packed together again. So you might think about this as, very roughly like our traditional wave form. It's not quite like this, but you'll get the gist of it, where every time they're packed together, that represents a peak. And then every time they're spread out, that represents a valley. So that's where you can kind of see this. So you imagine these particles are bouncing back and forth, left and right, and they get closer together, farther apart, closer together, farther apart, as they kind of vibrate back and forth. So to illustrate this, I'm going to kind of help you to imagine how we would maybe form a sound. So imagine I've got a cymbal here, like on a drum kit. And if I hit this cymbal, what's going to happen is it's going to vibrate up and down, back and forth really quickly. Vibrate back and forth, back and forth, back and forth. Well, what happens if you zoom in, I'll draw kind of zooming in, you've got the cymbal here, and when it vibrates up, it shoves all the air above it and gets it all really close together. So I have a bunch of air really close together here because the cymbal shoved that air up. So you got this big compression. And then the air above it, is maybe normal, so something like that. Then what's going to happen next is you're going to have it slide down because it's vibrating, so it goes down. And when it goes down, it leaves this gap of near vacuum because, all the air got shoved up, and then it swings down, and that leaves behind nothing because it doesn't pull any air with it. So that means that we've got this compression, a bunch of air packed together, followed by a gap. Now, because all these air particles got shoved, they're going to keep traveling, in the direction upwards, we'll say. So what happens later is then you have a bunch of these particles kind of all jammed together up here. Then you've got a gap, and then, slowly some air fills in from the sides or, it pulls down from above. But then you've got kind of a gap, and then what happens, the cymbal's vibrating, so it shoves up again, and you get another group of really packed together particles. So what ends up happening is as that cymbal vibrates, it packs together particles and shoves them along in like a packet, and then it leaves a gap behind them. Then that gap kind of slowly starts to fill, but then it shoves more together in a pack and shoves those behind it. But because of the way that physics works, there still ends up being a gap of pretty loose particles between these closely packed packets. And that's how we form a wave. Your vocal cords do the exact same thing. They vibrate, and so they make a compressed together chunk and then a gap, and then a compressed together chunk and then a gap. And that's where we get that. So next, we're going to talk about a couple of key terms with sound. So first, speed is just going to be kind of how we colloquially use it, how quickly sound travels. The amplitude is the difference in pressure between high and low zones. So if the packets of packed together sound or packed together air, excuse me, those packed together packets, if they're very high pressure and the gaps are very low pressure, that would be a high amplitude. If the pressures are pretty equal, that would be smaller amplitude. And this factor right here determines the loudness or the volume of the sound. So higher amplitude, bigger difference in pressure means louder sound. Frequency is how many vibrations or changes in those pressure occur each second. And this determines the pitch of the sound. So high pitched, you know, like flutes, if you're familiar with that, soprano singers, all the stuff that's really high pitched, it's kind of like irritating to hear if it's too high pitched, is a high frequency. Low frequency are your bass notes, your subwoofers put out low frequency, stuff like that. Then lastly, wavelength is the distance between those adjacent high pressure or low pressure zones. So that's where you saw when I illustrated earlier for you, drawing the kind of sketch of the traditional sine curve on top of the wave. You saw that between adjacent peaks or adjacent valleys was where you had the high and low pressures.